guys, welcome to the continuation of our lesson on basic trigonometric integrations. This is the second part of the lesson. Here we're going to look at further examples on the concepts, and these examples are past examination questions. Our first example. Our first example says evaluate the integral of sec square x minus cosecant x cotangent x dx. When you look at this particular problem and see that we have an integral for secant square x, and also we have an integral for cosecant x cotangent x. So the order we have to do is to expand with the integral and then the variable of integration. So we are going to get the integral of sec square x dx minus integral of cosec x cot x dx. We learned that the integral for sec square x dx is tan x, and the integral for cosecant x cotangent x is negative. So we have this negative cosecant x plus c, of which the answer becomes tan x plus cosecant x plus c. In this particular question, the problem says the integral of 3 minus tan x multiplied by sec square x dx equals integral of a particular integrand du if u equals 3 minus tan x. So meaning we should find a particular integrand over here which will complete this particular statement. That's what the question demands us to find. Let's see how we solve it. So already they've given us u. It says u is 3 minus tan x. So we're going to have u equals 3 minus tan x. Let's differentiate the u with respect to x, and this goes to 0. Then we know the differential of tan x to be sec square x, so the negative. Let's make the x the subject, and that will give us substituting. We are getting integral of, this is u, so we are going to have u, then sec square x, then the dx is this, of which this cancels this. So now we have integral of negative u du. You can see this matches what we have here, so we can say therefore the missing integrand is negative u. So that is the answer. Our next problem also says evaluate we should evaluate the integral of sec square x dx on tan x, and it is clear that if we let the u to be tan x and we differentiate tan x will produce sec square x, hence we can cancel out to simplify. So let's do that. Let u equals tan x, then we know that the u is equal to sec square x dx. Making the x a subject, we have the x to be the u on sec square x. When we substitute, we are going to get integral of sec square x on u, then the u on sec square x. This is sec square x and this is sec square x. Can cancel out. So now we have 1 on u du. Integral of 1 on u will give us ln u plus c, but u is tan x. We can conclude that our answer is ln of tan x plus c. Also, we have integral of cosine of x on sine square x dx. Here, note that the problem, this can also be written as cosine of x on sine x all squared dx. The reason why I've written it this way for us to see it clearly, let u equals sine x, and you know that the u is equal to cosine of x dx, and our dx is equal to du on cosine of x. When you substitute everything back, we're going to get integral of cosine of x on u squared du on cosine of x, which cosine of x cancel cosine of x, hence we are having 1 on u squared du. Of which you can also write that du. So integrating this, we are going to get negative u power negative 1. That's when we add 1 to that, plus c. So we're going to have negative 1 on u plus c, but u is sine x, hence we're going to go 1 on sine x plus c. From trig identity, we know that 1 on sine x is the same as cosec x, so you can also say that negative cosec x plus c is the answer. Also, we are to integrate cosine of x on 1 plus sine x dx. In this problem, when we let the denominator 1 plus sine x to be u, and we differentiate the 1 plus sine x, we are going to have cosine, which of course will cancel out this. So let's do that. So say let u equals 1 plus sine x, and now du is going to be, this go to 0, this becomes cosine of x dx. Dx equals du on cosine of x. Substituting, we are going to get cosine of x on u dot du on cosine of x. So just cancel that. Now we have 1 on u du, and integral of 1 on u is ln u plus c. U is this, so we're going to have ln 1 plus sine x plus c. That will be the answer. Our final example says to find the integral of cosine of theta minus sine theta on cosine of theta plus sine theta. A problem like this, you can see that if the denominator becomes the u and we differentiate, the differential of cosine of theta is negative sine theta, and this is cosine of theta, of which it will resemble the numerator. So let's do that. Let u equals cosine of theta plus sine theta. So the u equals, differential of this is negative sine theta, then differential of this is plus cosine theta, the theta. So let's make the theta the subject. So we're going to get the theta equals the u on cosine of theta minus sine theta. I've rearranged it. So substituting everything into this, we're going to have the integral of cosine of theta minus sine theta all on u dot du on cosine of theta minus sine theta. And you can see that this is the same as this. So everything becomes integral of 1 on u du. And we know that will give us ln u plus c. Finally, we can say that our integral becomes ln of cosine of theta plus sine theta plus c. Thank you very much for watching. Please subscribe, share for more videos. Bye bye.